Hey guys, just wanted to do a couple of different tests with the Voodoo hitch here. And what I'm wanting to see is, right now we have 3 different carabiners as our friction points and as our change of directions to make up our mechanical advantage. I'm going to see how much force we're able to get in total just with my bare hands on this enforcer with this setup, and then we're going to replace one of these carabiners and with a pulley, see how much force we can get, and then ultimately we will have 2 pulleys and 1 carabiner to see how much force we will have. You have to have at least 1 carabiner in a Voodoo hitch to have the friction necessary to hold it all in place after you tension it. Just to be absolutely sure, I did do it with 3 pulleys the other day, and it definitely did not hold its tension. All right, so with the 3 carabiners with that much friction right now, just by myself, without really yarding on it or jerking on it, we've got a holding force of 0.32 kilonewtons. And the max force, again, without jerking or anything like that, while I was pulling on it, it got up to 0.66 kilonewton. So now we're going to replace one of these carabiners with a pulley. We'll just do this one, and we'll see what we're able to get.
How does it?
All right, so now we've got a single pulley. Still have the 2 other carabiners. And doing the same thing as before, pulling the exact same way and without jerking, it's holding at 0.52 kilonewtons with that max, that peak being 0.86. So now we're going to replace another one of these with a pulley. I think we're just going to do that one at the other end and see what we're able to get it up to. All right, so now we have 2 pulleys, 1 carabiner, and actually originally this pulley I put over there and it was not holding the tension nearly as well as when I put the pulley here. And I think the reason for that is that actually this pulley being here, it's farther away from this pulley. And so there is a friction point between these 2 pulleys, which I think ultimately is going to be enough friction to hold everything. So I tightened it down the same way as I did the other times, and now it's holding at a force of 0.78, 0.76 kilonewtons with a max force of 1.88 kilonewtons. So now what I am going to try, so this is the original knot I tied in the first iteration, and you can see how much closer we've arrived to this anchor side from when we were originally doing things. So I'm actually going to see what happens when I move this knot down and we have it set up over there, and we have this same setup with these 2 pulleys and that carabiner on that side. I'm wondering if taking rope out of the equation, tightening it down a bit more, will give us a different number here on the enforcer. All right, so I redid it so that butterfly, after it was tightened down, is a lot closer to that side of the system. And so we actually took out a decent amount of rope from the Voodoo hitch. And doing that, ultimately, we were able to get 1 kilonewton of force holding on this. And for our max, we had 1.5. And I apologize, on the other one, I forgot to reset the max. So that was actually after vectoring on this a little bit. And so it was not 1.88, it would have been closer to 1. It was about 1.08 kilonewtons. So the max force I was able to apply into this as well is significantly higher than when the knot was much closer to this side of the anchor. All right, just because I'm curious, we went ahead and we threw the enforcer on this opposite side because there's more mechanical advantage on this side than over there, just to see if we would get a higher peak force pulling the exact same way as I was on the other ones. And the peak force on that other side with this same setup was 1.5, and this got up to 1.86. So doesn't mean too much, not necessarily, but just an interesting observation.